In this video, we want to talk about the p-value. So for p-value, it's very similar to the test statistic. The only thing is that p-value is probability value. It's very similar to alpha. The only thing is that alpha comes from the confidence interval, right? So we would say we have 95% confidence interval. We're looking for the 95% confidence interval, so alpha is going to be 5%. With the p-value, we would say that whatever your test statistic was, right? Because alpha would give us the, okay, let's say it like this. We had the confidence interval, we will find that the alpha, and then we would go to the table and read the t, for example, or z critical from the table. So that was the critical value that we would find for the alpha. But with the test statistic, what we said that test statistic, whatever you find out is the observed value. So we would call it T observed, or we would call it Z observed. Now think about it. If we go back to the table from the T observed or Z observed or F observed, chi square observed, all of these ones, like whatever observation that you have, you make your test statistic, from your test statistic, you're going to get the value for your T or Z or chi square or F. And then we would go, if we go back to the table and we were interested to find out the related alpha for it. In that case, we would call that new alpha, we would call it p-value. What does it mean on the table? Before going to the note, lecture note, I want to show you this because it's very important to know understand the concept of it. It's a little tricky. So we said that this is the T critical, right? So we had our alpha, for example, we said that this was half of the alpha, and then we would say this T critical is based on this alpha and the number, like the sample number, the data points that we have, like n, whatever that we have for the n-1, like the graph of the critical. So now, when we had an example and we said that, okay, so this is an example. If the T observed was greater than the T critical, so we would say this length would be the T observed. And then we would say we reject the null hypothesis because we are in this area. So now, if I go back to the table, look at here, and find out this value. This value is your p-value. So whatever alpha you read, like whatever probability, because alpha is a probability, is area under the curve, but for the outside the confidence interval, right, is the significance, we call it significance level. So if you go back to the table and read it in a reverse mode, in that case, you would call it p-value. Now let's look at the concept behind the p-value. So let's go and look at the note for the p-value, lecture note. It's on page 54. So the concept is schematically, so you can see that here, this is the, when we wanna, if you wanna draw it. Commonly, the value of alpha is set as 1% or 5%, like that. You are working with the 95% confidence interval or the 99% confidence interval, industrial application. The philosophy behind setting this value to control the probability of rejecting the correct null hypothesis. So that's the reason. But there is something that, what about if the test statistic value is very close to the critical value? What about your T observed, like this T observed that you find, or Z observed from the test statistic? It's very close to the T critical. How can we make it decision in that case? An alternative to pre-specifying the value of alpha is to calculate the probability of exceeding the value you observe given the H null, and we call it the p-value. Like if you go back to the table and read the alpha again, it's a new probability. In that case, we call it p-value. And we have some rule of thumb. So the amount of evidence for rejecting the null hypothesis is then given accordingly to the following guidelines. If your p-value is less than 1%, we will say we have a very strong evidence to reject the null hypothesis. So think about it, it's like that. I have a strong evidence to reject the null hypothesis. So it means that I should be far, far away from the T critical. So when we are looking at it, it's less than 1%, right? So it's like that, for example, you have a small portion here. So you are far from the T observed. So you have a strong, very strong evidence to reject your null hypothesis because you're far from the null hypothesis. It makes sense. So instead, it's like this. If we try to have it like, if we try to visualize that and learn the concept, like instead of memorizing that, you will see that it's very interesting. So maybe that's one of the reasons that we have many people that they are working as data analysts in a larger scale. But the basic is this, like the source of all of those data analysts that you see outside is that you could decide that when you see your p-value is like between 1 and 25%, you could say that, okay, so you have a strong evidence. So we need to visualize that in our brain quickly and find that also null is in between. So probably we are far, far away because it's just that 1%, like between 1% and 25%, 0.025. And then the one that we have here, look at this one. If your p-value is between 5% and 10%, in that case, you have weak evidence for the rejecting the null hypothesis. So you would need to, with that data points, we cannot say that we reject the null hypothesis. We need to get another set of data, and we would need to go with another methods that we would have. Okay. So let's wrap it here. We learned about the general hypothesis, like the methods that we have, and then the p-value. It's good that if you look at the tutorial of with the title chapter 1, example 3 and example 4. So it's example on the hypothesis testing. In the next videos, I'm going to talk about the hypothesis test or inference, statistical inference, meaning confidence interval and hypothesis, when we have more than one sample. That's all for now. But please look at the next video.